Hello, welcome again to this channel. This is where we present solutions for your needs. Now let's continue our discussions on circuit analysis in DC. We have the laws. The first law that we will discuss is Kirchhoff'S Current Law, or what we call the KCL. It is defined as the sum of the currents entering a node, which is equal to the sum of the currents leaving it. So the currents entering is equals to the currents leaving. In this case, we have here an example of a circuit, and we have here a node. A node is a point where the branches are connected. So we are to assign a current here. For instance, the current here is going to the node, and let us name this as I sub 1. And from this node, it was broken down to three. Other one named is I2, the other one named is as I sub 4 current. So based on the definition, the current that enters a node is equals to the current that leaves the node. So if you are going to get the Kirchhoff's current law here, we say KCL at node A. KCL here is this is the current that enters a node. This is equal to the current that leaves a node. So these currents I sub 2, 3, and 4 leaves a node. So you just equal it to I sub 1. So it will be I sub 2 plus I sub 3 plus I sub 4. So this will be the Kirchhoff's current at node A for this circuit. Now let's consider another typical direction of the current. For instance, current is going there again. This is I sub 1, and the current here goes to the node I sub 2, and another current for the resistance R3, which is I sub 3, and this one is going to the node also I sub 4. So to set up the Kirchhoff's current law, again the KCL at node A will be current enters a node equals the current leaves the node. Okay, so this one is entering a node, so that is I sub 1, and this also enters a node, so that will be plus I sub 2 and plus I sub 3 and plus I sub 4. And there is no other currents here. It's all enters a node, so this is equated to 0. So another typical example is this one. For instance, we assign a current, it leaves the node. See, this is I1. This one leaves again the node A, and this one enters a node I sub 3. This one enters a node I sub 4. What is the Kirchhoff's current law here? The KCL here at node A is simply as the current that enters a node or I sub 3 and this added to I sub 4. It all enters a node, and the other currents leaves a node, so you just equate that. So I sub 1 as I sub 2. Okay, so this is the Kirchhoff's current law.